Hello, Michael White here, reading from the 7th grade science textbook. We are in Chapter 2, Lesson 3, Graphs in Science. My Planet Diary. Waste and recycling data. The information below shows the amount of waste generated and recovered for recycling per person per day for each year listed. 1980. Generated waste was about 1.6 kilograms. And recovered waste was about 0.16 kilograms. 1990. Generated waste was about 2.04 kilograms, and recovered waste was about 0.33 kilograms. 2000. Generated waste was 2.09 kilograms. 2002. Generated waste was about 2.09 kilograms, and recovered waste was about 0.61 kilograms. 2007. Generated waste was about 2.09 kilograms, and recovered waste was about 0.70 kilograms. What kinds of data do line graphs display? Could the saying, "a watch pot never boils," really be true? Or does it take longer to boil water when there is more water in the pot? You could do an experiment to find out. The table in Figure 1 shows data from such an experiment. But what do the data mean? Does it take longer to boil a larger volume of water? Line graphs. To help see what the data mean, you can use a graph. A graph is a picture of your data. One kind of graph is a line graph. Line graphs display data that show how one variable, the responding variable, changes in response to another variable, the manipulated variable. Using line graphs. Scientists can control change in the manipulated variable. Then they collect data about how the responding variable changes. A line graph is used when a manipulated variable is continuous, which means there are other points between the tested ones. For example, in the water boiling experiment, many volumes are possible between 500 milliliters and 2,000 milliliters. Why are line graphs powerful tools? A line graph in which the data points yield a straight line is a linear graph. The kind of graph in which the data points do not follow along a straight line is called a nonlinear graph. As shown in Figure 2, both kinds of line graphs are useful. Line graphs are powerful tools in science because they allow you to identify trends, make predictions, and recognize anomalous data. For example, the graph of experimental data in Figure 3 on the next page shows that the trend is linear, even though most points do not fall exactly on the line. One point is clearly not part of the trend. It is an anomalous data point. Graphs make it easy to see anomalous data points like this one. When a graph does not have any clear trends, it probably means the variables are not related.